we are going to be talking about the 9100D, and which has been a very successful product since we launched it last year around October. And as you all know, and this is, you don't know, actually. This is from last week. We just won the best product during the Sensor Expo. I was on the plane, so I couldn't receive the prize, but my friend Bruce here in the middle was kind enough to be in Chicago to get the prize for us, and I'd like to share this prize with all of us. You know, this product is being a great success. The guys, all of you have demo units in your country, and you've been taking those the 9100D to trade shows. 2 weeks ago, the 9100D was at a show in Brazil and was a huge success, called a lot of attention. So all in all, we are very pleased, and that's why we want to talk again about the 9100. And just want to start with a quick overview, and for most of you, I would just call it a quick review. You know, some of the great things about this product, as you know, it's a small, it's a battery powered, it's portable, and it's very versatile, as it can do, you know, calibration of accelerometers, velocity, transducers, and also proximity probes. The product is self-contained. It's very rugged and lightweight and very precise. And it has a very nice frequency range from 7 Hz to 10 kHz. So those are all great features that provide, you know, a wide variety of applications and support out there. In terms of sensor calibration, we are all familiar with, you know, how to calibrate accelerometers. This is a picture mounting the accelerometer to the shaker top. And a lot of times, you know, customers bring the sensors to the lab and get them calibrated. But what I want to emphasize today is, you know, most of the time that we sell this product, we're doing the opposite. You know, we are taking the calibrator to the sensor site, and that's the concept that we call the in situ calibration, where, you know, you have customers, primarily industrial customers, with big machines like the steam turbine you see on the picture, and those machines are instrumented with several different sensors. A lot of those sensors are vibration monitoring sensors, and there is a need to verify if those sensors are actually working properly. So the concept of in situ calibration guarantees not only that the sensor is performing according to the specs, but also it's a tool to verify the complete measurement chain. You can call it like it's an end-to-end calibration. Those sensors are typically connected to a vibration monitoring system or a digital control system, and you may have a control room with you know, all the monitoring indicators of the status and the health of the machines throughout the plant. And why is this important? The main reason we do that, you know, is to confirm that the alarm trip points are set properly. So the most customers that buy our unit, they're not that much interested in doing like a calibration certificate. You know, they want to know if the monitoring systems are working properly, if the right levels are being monitored. And one of the benefits of the 9100D I can dial the exact vibration level that's being monitored. So if my system is set up to create an alarm if vibration exceeds 3 Gs, I can go on my amplitude dial and dial up 3 Gs. If it's 3.5 Gs, I can dial 3.5 Gs. And more than that, because there is a variety of sensors that are used out there, not only accelerometers, sometimes people are using velocity sensors, sometimes people are using displacement sensors, I can dial the exact unit that's being monitored. So if I'm monitoring a certain velocity level, I can, set up my 900D to velocity and put up the exact value that I'm interested in. And when it comes to accelerometers and velocity sensors, we as PCB group people, we are very familiar with accelerometers. That's what we do every day. And in terms of, mounting aspects, even if you have velocity sensors, some velocity sensors are piezoelectric, but a great amount of them are electrodynamic, where they have like a moving coil, magnet, a little bit larger than an accelerometer. But either way, there's always some type of mounting involved. A lot of times just a stud mount. We provide, as a standard with every system, we provide a set of mounting studs and a little mounting pad adapter. There's also a mounting kit available. So there's not much secret there on how to use the product to test accelerometers and velocity sensors. So what I want to emphasize on today's presentation, I want to talk a little bit about proximity probes. And the reason I want to do that is because approximately 20% of the systems that we sell, they go out with the proximity probe fixture as an option. And I'm not an expert in proximity probes, and most of us are also not experts in proximity probes for the very simple reason that PCB does not make proximity probes. So I was the other day, I was scratching my head, and I said to myself, I think I want to learn a little bit more about what they are, and since my customers are using my product to check those probes, and just trying to understand a little bit more of that type of application. And those are very precise displacement transducers. They provide a voltage output. They are eddy current sensors to start with. And once it goes through a little box, little power supply, what you get out of those transducers is a voltage output that's approximately 200 millivolts per mil. A mil is 1,000th of an inch. If we translate that to metric, we are talking about 7-8 millivolts per micrometer. So those sensors can measure really tiny gaps, and because they are non-contact transducers, they can be mounted directly close to the shaft that is rotating. So it gives you a very effective method to quantify the shaft vibration and even the shaft location that normally, you're talking about a shaft that's supported by journal bearings or oil bearings. And those are very common in turbo machinery like compressors and turbines and pumps. And this technology was pioneered by an American company called Bentley Nevada. That company still exists. It's one of the very big companies in the vibration monitoring business. They are now part of General Electric, GE. And they start doing this in the late 60s and 70s, and that's it's pretty much a standard technique nowadays for monitoring those machines. So back to our example, when you look at a steam turbine like the one on the picture, you're going to find not only accelerometers monitoring the vibration, but you're going to find a large amount of proximity probes being used to monitor that particular machine. And this is just the next picture you see, a more a sketch on what a turbine looks like, and you have the different sections, the high pressure, the low pressure, the generator, and all those parts of the turbine have bearings, and those bearings you will find at least 2 proximity probes per bearing. They are set up in a 90 degrees XY position. So you can measure not only the dynamic displacement, but also with the X and Y you can tell the orbit. You can measure the orbit and how the shaft is moving. So again, this is just a description of the typical locations you will find the proximity probes in a turbine supervisory instrumentation. And you're checking for all sorts of problems and things that can happen, like unbalance, misalignment, and cracked parts and shafts, and also other dynamic instabilities. If you look at what type of measurements that are being taken, this is just an example there. You can measure the radial vibration, and for each prox probe you get a dynamic signal, and you can look at the RMS or peak level of that signal and translate that into an alert or a shutdown point. Same thing on the axial direction. Since those are turbines, you're going to find a lot of thrust and energy going not only on the radial but also in the axial direction. So one thing that I want to emphasize for this particular application, it's not just the monitoring system that we're not just monitoring vibration, but people call this surveillance systems. The idea is to, those systems are wired to shut the machine off. And the reason for that is safety, is to avoid a catastrophic failure. If those machines fail, they're not just going to break. It's going to be literally a catastrophic failure. And because of that, and because, a lot of those, you see a lot of turbine machinery in the oil industry, they've taken the step forward, and they've done a great effort to standardize what type of protection systems that you expect to see in this type of machinery. And in particular, the API, the American Petroleum Institute Standard 670, describes to a great length what you have to do. And one of the things there, there is a requirement for calibrating the prox probes. So essentially, any of those customers, when they install the surveillance systems in their machines, they are required to check if the systems are in place, if the systems are working. And they do that using the 9100D. And again, to avoid catastrophic failures. And people are asking, okay, what's a catastrophic failure looks like? And you don't want to see this picture, but that's kind of the, what happens when something goes wrong. This is just this is a picture after the fire has been extinguished and after, the place has been cleaned up. But you had, metal pieces flying through buildings and through walls, and it's really, really ugly. So back to business. So let's talk just for a few minutes. So how do we use the prox probe fixture with the 900D? And it's very simple. For those of you who haven't seen it, we have a little bridge support, and that holds a prox probe and holds a micrometer. And the micrometer allows you to move this little black piece up and down, therefore allows you to move the prox probe up and down. So you move the prox probe away from a target, and that target's made of a particular type of steel. So you get that's how you measure the performance of the prox probe. Just on the next picture, you have a little exploded view of all the components in the prox probe kit. Those pictures are on our website for if you want to look into more detail. And here's I'm highlighting the target that we supply with the prox probe adapter kit. And to give you a little bit more detail on how to use it, we just uploaded a short video. It's a minute and a half, 2 minutes video. It's on YouTube right now. It's going to be, I think it's going to be on our video vault pretty soon if it's not there yet. And that shows step by step how to set up the prox probe adapter kit. And so it's very easy, and doesn't take more than a minute or two to get it set up. And here you see the prox probe going through the apparatus and close to the gap and close to the target. And essentially, this is a type of measurement that that's the result that our customers are interested in. So essentially, you start with the prox probe very close to the target. Typically, we're talking about a quarter of a millimeter away from the target, or 10 mils, and you move the prox probe away from the target, and the way they are powered up, you get a negative voltage out. So if you are about 50 mils or halfway through the linear range of the prox probe, 1.25 millimeters, we are talking, you expect to see about a minus 10 volts DC coming out of the prox probe. So you can do that test with the shaker turned off. It's just a static test. You just move the prox probe away from the target. And that's what most people do out there. But a very interesting capability of the 900D is, it allows you to do also a dynamic test of the prox probe. So I could easily set up my prox probe halfway through, like a 1.5 millimeters from the target. And then I can turn my shaker on at, let's say, 50 or 60 hertz, and put a certain amplitude of vibration there, and just watch out what's the output and the AC output, and that will be a simulation of what you see in the real world with a shaft that's vibrating at that same particular level. And if you look at this line, you expect to see this is like a 200 millivolts per mil type of output. And you need to do that type of testing. Your customer needs to do that type of testing for every prox probe that's installed on the machine. So basically, that's that concludes my presentation. Just reminding them. The target customers out there for the prox probe option, you found them mostly in the energy and power generation fields. oil and gas and power plants. And of course, you find a lot of the people that are servicing those machines. So it could be a consulting company, a service company that goes out there and service the machine. So not necessarily the customer that owns the machine. Those are mostly industrial customers, IMI customers, and they are, every country out there, you find this type of industrial customers. So I'd like to thank you all for being here today.